guys, so we're in journal 29 here, and we're going to start off with a Bellwork that seems like some problems you might have seen in geometry. So all you're asked to do here is to draw an example of each type of these triangles. Now, if you remember, S stands for side, A stands for angle. So this is saying, like for part A, you have a side of a triangle and you have two of its angles, and those two angles need to be side by side of each other. So if I were to, draw a example of that, that could be something like you have an angle, let's say B, I'll just call it B, and you have some angle C, and they're side by side, so that's why it's angle, angle. And then you have, a side length C. So in this case, you would have a side and two angles. So this would be an example of, a side and two angles. And then in this next one, you have an angle, side, angle. Notice how this side is between the two angles. So you need to make sure when you draw your triangle, let me do it that better. When you draw your triangle that you have two angles. So let's call that B and C again. And then between them, you have, little a. So you have a side. So now let me try to make this a little bit more interesting by actually using numbers. So like for part C, say you have another triangle and you have a side, angle, side, it looks like. So side, angle, side. So that means you have, between your sides, you have an angle. So let's call this angle, 30 degrees. And then you would have two sides. So let's call this not a size of 9 and this one's size of 10. This could be 9 inches, this could be 10 inches. So you have two side lengths and an angle, and the angles between the two sides. So this would be a perfect example for this scenario. If you have a side-side angle, that means the two sides need to be next to each other. So maybe I'll use that 9 and 10 again. But now the angle is right here. So in this case, this would be 30 degrees. So that would be referred to as a side-side angle. And then our last but not least is SSS, or side-side-side, meaning you have all three sides. So let's call this 10, 9, and 8. So you have all the side lengths but no angles. So this, in geometry, you use this to help you find, I think, congruency, like how two triangles, if you know that they're congruent, that you can find, things about it that help you find the other lengths. Now for us, I want us to know these categories, these 5 categories, so that way we can figure out what type of triangle we have. Not necessarily about how it's congruent or anything like that, but just so that we know what type of triangle we're dealing with, because we will need them when we refer to certain formulas that you will learn, various ones in this chapter. So let's get on to today's lesson. So in today's lesson, I want to talk about triangles. And in fact, this entire chapter is about triangles, but it's not just any triangle we're talking about. So we've talked a lot about right triangles, because right triangles allows you to apply Pythagorean theorem and those sine, cosine, tangent rules. So SOHCAHTOA is really highly used when you have a right triangle. But everything blows out the window if you don't have a right triangle. So what I mean is things that are not right triangle is what we call an oblique triangle. And let's pretend that, here I have this oblique triangle. And the thing about oblique triangles is we're still going to refer to them as some angles and then the sides. So I always refer as angles as being, big letters. So I'm going to call this big A. I'll call this big C, and then big B. And so diagonal from them is the lowercase letters, which represents the side lengths. So diagonal from this A is little a, diagonal from this B is little b, and diagonal or across from C is little c. So this is how I refer to. So lowercase letters are side lengths, uppercase letter are angles. So using the laws of sine, which is a proportion of the lettering with its side and its angle, apparently when you create a proportion between the side and the corresponding angle, they are equivalent to every, angle that corresponds with its side. So in this case, we can allow this to be like a type of formula or a type of equivalence that we can use, but we only want to use the laws of sine when you have two angles. So when you have a side angle, or when you have an angle, side angle. So when you have two angles, you want to see if you can use the law of sines, generally. So in this case here, we're going to do some practice problems where we're using the laws of sine, and I'll show you how you can use it. Okay, so in this chapter here, we're going to be doing homework problems from 20.1, problems 30 to 20. So I picked out 4, and all it's asking you is to find the length of A. So here's the length of A, it's little a, and you have to figure out what is little a. So the nice part is that you're actually given the angle of, big A, and you're given the angle of C too. You're not given the angle of B, but you could easily find it. Like if I were to find it, isn't that like 180 minus the angles that I'm already given? So 150, what would that be? Let's do the math. So what's 180 minus 45 minus 105? Well, that's about, if I add that, I better grab a calculator, but I believe this would be 30 degrees. So in this case, I know that big B, or the angle B, is 30 degrees. So this is kind of cool, because this means that I recognize that I have the angle B, and I also have the side B. So that means I can create a equivalence, or proportion, where I can say B, little b, is over sine big B, the angle. And because I want to figure out what A is, all I have to do is use the proportion of B with the proportion equivalent to A if I have all the pieces. And I actually do. So notice how I have little b, it's 10. I have the angle for B, which is 30. I don't know what A is, but that's perfectly fine. I can, try to solve for that. And I do have the angle A. So I'm going to plug in what I know. I know that little b is 10. Sine here of B is 30 degrees. And this is equivalent to little a and sine of A, which is 45 degrees. So if I were to solve this out, I need to, get my A to be by itself. So to do that, I have to try to, get it down from that fraction. And one way you could do it is cross multiplication is a way you can get rid of the fraction. So A times sine of 30 is A sine of 30 degrees is equal to 10 sine of 45 degrees. And then from there, I notice that I can divide by sine. Notice that I'm trying to get A by itself, so I have to divide sine 30 off of it to try to get the A by itself. So that means A equals this piece right here. So I'm going to have to use my calculator to calculate this. So I'm going to figure out and make sure your calculator is in degrees since it's in degrees. So figure out what 10 times sine of 45 degrees divided by sine of 30, which gives me approximately, if I round to 2 decimal places, 14.4. So it looks like A is about 14.4. And that's my answer. So I can use the law of sines to help me figure out the side lengths. But yeah, so we're going to take a look at a few more problems where we use the laws of sine to get some more practice in. Okay, so here's another problem where we need to determine the remaining sides and angles of the triangle. So first off, I'm going to list out what I need to find. It looks like I don't have one of the angles, which would be very easy for me to find since I know that all triangles add up to be 180. So I have to figure out what big C is. I don't seem to know what little b is. And I don't know what looks like, I think this is little a. So in this case, I need little a and I also need little b. And I do have little c though, which is kind of nice. So right now what I'm going to do is figure out what's the angle, since that's the easiest thing to do. So if I take 180 and subtract from the angles that I already currently have, it looks like I get about 95 degrees. So I know that C here is 95 degrees. So if I know what C is, and I know what little c is, then I can create a proportion to figure out the other, sides. So I'm going to use little c, which is 18 over sine of 95. So this is showing the relationship between c, the side, and the angle. And then I want to equivalent that to, let's go find a first. So I have little a that I want to find, and the angle for little a is 37. So I have little a divided by sine of 37. And so I've created a proportion where I will try to solve for this a right here. So again, cross multiply. So that way you can get rid of the fraction. So this is 18 times sine of 37 degrees, a times sine of 95 degrees. And then we're going to divide off sine of 95 degrees to both sides to cancel out the 95 on the left-hand side. And then a comes down. So let's figure out what 18 times sine of 37 degrees divided by sine of 95 degrees. I got 1087 as my answer. So in this case, it looks like that is one of my values, 1087. And I'm just going to round to 2 decimal places here. And it does say that it's in meters, so I might as well write meters there alongside it. Now it looks like I just have to find B. So here's the nice part. Because I already found like the angle for C and the side length for C, I can just reuse this piece, the equivalence of just C itself. So I'm going to do 18 sine over 95 again. But this time around, I'm going to set this equal to little b and whatever its angle was, which was 48 degrees. And then solve, for my b, but in this case, I have like a different angle that I'm working with. So I'm going to cross multiply. So this gives me b sine of 95 degrees equals 18 sine of 45 degrees. And then I have to divide by sine of 95 degrees to both sides. So that cancels. So it looks like, let me make this smaller, there we go. B is equal to 18 times sine of 48 over sine of 95, which is equivalent to 13.43. So 13.43 meters. And then this here would be my completed answer. Let me grab a highlighter. So that's all 3 of the pieces that are missing. So I hope that helps you out and gives you a better idea how you can solve an entire triangle using laws of sine. Let's do one more together. So again, I'm going to try to make a triangle first so I can figure out, what sides am I already missing. So here's my triangle. And in this case, I have, let's say A, big A, and it's 68.41 degrees, like they said. Big B is 54.32 degrees, and I don't know what C is, but they do give me little a, which is 12.75 feet. And so I'm in search of what is angle C, which probably won't be too hard to find, little b and little c. So I'm going to be finding big C, little b, and little c. So let's start off by finding the angle, because I just have to take 180 and subtract it from all the angles that I've already been given. And so in this case, if I subtract by the angles that I'm already given, this gives me about 57.27 degrees. So I know this piece now. So what I also noticed that is, like, I have the equivalents for big A, the angle, and little a, the side. So I have all the A values, it looks like. And so, like I said, I know that I have little a, so 12.75 divided by sine of 68.41 degrees. And I'm going to try to find b first. So if I were trying to find b, I can set that equal to sine 54.32. And so from here, I need to solve this out. So I'm going to grab my graphing calculator here. And well, I guess before I use my calculator, I need to, cross multiply so I can get the b by itself. So this gives me 12.75 sine of 54.32 degrees. I forgot my degree sign. And then this would be b sine of 68.41 degrees. Then I just have to divide off this sine of 68.41 so that way I can get the b to isolate. So it looks like b here is equal to 12.75 times sine of 54.32 degrees divided by sine of 68.41, which is 11.1, if I round, 14 for the length. So I got my b. If I want to figure out what c is, I do the same thing. So here's the nice part. I already have the equivalents for my a. So this is just the proportion for the side length for a and then the sine of a. So instead of having b here and b's angle, I'm going to have c's angle and c's the variable here. So I'm going to scooch this over. So I'm going to rewrite the first part the same. So this is just the side length of A and then the angle for A. And this is going to be equivalent to B over sine of B, which is the angle 54.32. And I need to cross multiply so that way I can figure out what B is. So in this case, B is multiplied by sine of 68.41 degrees equal to 12.75 sine of 54.32. So if I divide by sine of 68.41 and I divide this side by sine of 68.41, that cancels. And so in this case here, I have B is equal to 12.75 times sine of 54.32 divided by sine of 68.41. So I'm just going to type this in real quick. So it looks like I got 11.14 again. Interesting. I didn't use the wrong, I'm trying to think if I used the wrong degree, but it doesn't look like I did. So it looks like both answers are 11.14. The angles are very close together, so it doesn't really surprise me. It looks almost like an equilateral triangle, like very close to. At least two of the angles are very close to each other. All right, so I hope that gives you an idea of how to work with the laws of sine. They just help you solve out a complete triangle, especially when you're not given a right triangle. So if you're given a triangle that doesn't have a right angle, then you can still find the sides, you can still find the angles, you can use it using the laws of sines for now. We'll learn other rules here in the next lesson.